Here's a demonstration of running the declination motor. So yesterday I completed the splice and service loop of the motor and brake cables. Here's the service connection for the motor, and this is the connection for the brake. I'm using the polar axis setup because I know it works. And I'll start by releasing the brake, which means powering the brake. Should be able to hear it. All right, so the brakes are off. I'm now going to move the motor in the positive direction, which is to the north. We'll start off with, say, 50% power. Let's check to see what's happening out here. It is moving up slowly. On the hand paddle, we can see declination is going north. So let's try bringing up the power to 99% open loop. Okay, now it's moving a little faster. Try to hold still so you can get an idea of what's happening. Maybe 1 degree per second. Let's look at the hand paddle. So close to 1 degree per second. It's quite variable. I'm not surprised that this axis is harder to move because it's not on hydraulic bearings. But it is moving. So let's just go ahead and kill the motor. So I'll just give it 0 current. Let's let it coast to a stop. Friction's pretty high. It stops right away. I know in the old days they tried slewing open loop, probably to get the speed that we desire. But gave up on that because you're out of control basically, especially on the polar axis. On a nice warm day, it's really going to fly along. You don't really want that. Better to go a little slower and be under control all the time and have the benefit of fatal following error and the other safeties on the motion controller. All right, that's the demonstration for today. I have to admit this is about the 3rd time I ran it. The first time I was too nervous to video anything, as you can imagine. The task for next week is going to be tuning the motor. I don't have a position loop encoder, so I'll be tuning it with just the encoder on the motor for the velocity and the position loop, and then doing the arduous wiring to complete the declination axis. But it's just going to be a copy of the polar axis, so it's just going to take time, not effort. That's all for now.